Hey guys, so in this video we are looking once again at applying algebra and making these types of algebraic expressions out of these worded problems or different types of problems. Now, this will hopefully be a shorter video because I discussed this a lot in my Year 7 series. So I'm just going to spend this video just going through some different types of examples which were different to the ones from that video, just to give you guys an idea of how algebra can be applied to different topics. Because by now, you would have, come across a bunch of different topics and you've especially come in contact with geometry and measurement and stuff like that. So you will hopefully be able to, by the end of this video, see how algebra can be applied to this. Now, a lot of the worded problems we worked on in the Year 7 series, it doesn't change too much, to be honest, between Year 7 and 8. So we're just going to look at some different types of questions in this video. So the first is we're looking at measurement here, and area and perimeter too. Now let's pretend this is a regular pentagon. Now, what do I mean by this term regular? It just means that all of the sides are equal. So I'm showing that by drawing these little lines, and they all have a side length of x. Now, in part A, I want you to find an expression for the perimeter. So we're going to try to take what we know about perimeter, about the fact that this is a pentagon as well, and come up with an expression for this perimeter. And it's going to be an algebraic expression because we have an algebraic term. We have a letter here. So since this is regular, all these sides are equal. So all of these sides are going to have length x. And we're looking for the perimeter. So what do we mean by perimeter again? Well, we mean the length of the border, the length around the shape. So the total length going from here to here to here to here to here, that is the perimeter. So in essence, I want to find all of these lengths and I want to add them together to get my perimeter. So this thing here, perimeter, I can write as a sum of all of my different lengths. Now, these are all lengths of x. I'm going to write this out the long way, and hopefully you'll be able to find a way yourselves to shorten this too. So my perimeter is x plus x plus x plus x plus x. I have 5 x's all adding together, and to shorten this, right, because I don't want to write all these x's being added together, multiplication gives us a way of abbreviating a bunch of additions of the same number. So we have here 5 lots of x. So we can shorten this addition by just writing that perimeter equals 5 times x, or 5x. We have 5 lots of x. And, okay, let's look at another part of this. Let's look at a question here, question B. So if each side length is increased by 3, write a new expression for the perimeter. So each side length increased by 3, we want to find the new perimeter P. So let's just redraw this and we'll make it a little bit bigger. So I have this here, here, fix that up a bit, here, oops, here, and here. And let's pretend if I drew this a little bit better, that all of these would be equal, that this is a regular pentagon. So what are my new lengths? Well, it's just 3 more than x up here. So how can I write 3 more than x using maths? Well, I can write this as x plus 3. And I have x plus 3, because all of these sides are equal. X plus 3. Nice. So, once again, the perimeter is the length of the border. The length of each of the sides. So what I'm going to do is I'm going to add these all together. So I can write this as my perimeter equals, well, x plus 3 plus x plus 3 plus x plus 3 plus x plus 3 plus x plus 3. Okay, so that was hopefully tedious for you guys to watch, because if that felt like it went for a long time, that's probably good, because you're already thinking about, well, what's an easier way, like a little shortcut I could do to this, and express all this information in a simpler way. Well, let's just consider how many x plus 3s we have here. I have 1, 2, 3, 4, 5, and all of these are adding together. So once again, I can write my perimeter as 5 lots of x plus 3. So that yellow looks really gross. Let's just circle them instead. So I have x plus 3 plus x plus 3 plus x plus 3 plus x plus 3 plus x plus 3. I have 5 lots of x plus 3. Now with algebra, I can shorten this. Instead of writing this multiplication, I can just write this as 5 outside the brackets of x plus 3. Now, just a quick question. This should hopefully look familiar to you guys from previous videos. This can be expanded. There is a number outside these brackets that is multiplying by what's in the brackets. And we've dealt with these before. This, we can do what we call expanding, if we remember. This, to recap the last video, this is the expression for the perimeter in factorized form. Now, we can leave it like this, but just to revise the previous concepts, we can also expand this. We can do 5 times x, that gives me 5x, and 5 times 3 gives me 15, positive 15. So that is going to be my answer. And you can see we've taken something really complex and weird looking and made it into a very nice and compact algebraic expression. This is what algebra is all about here. It makes things easier for us. It makes it easy to represent unknown bits of information. And now what I can do is, for any value of x here, I can find what the perimeter of this pentagon is going to be. And all I'm going to do is just substitute whatever value x is into my final simplified expression. So let's do one more question. We'll do a bit of a harder one. Once again, I'm going to apply this idea of measurement to show you how we can go sort of cross different disciplines of maths here. So I have here a rectangle with the following dimensions. And I want to find both the perimeter and the area of this. So part A, I want to find the perimeter and the area. I've just written these as P and A because I'm not bothered writing it all out. Well, if this is a rectangle, first of all, let's just fill in these other lengths because opposite sides of a rectangle are equal. So this side's also going to be x minus 3, and this side's also going to be y minus 4. Now, let's first find the perimeter. Now, the perimeter, once again, involves adding all of these sides together. So, what I'm going to do to find the perimeter, well, I'm going to say that this is just x minus 3 plus x minus 3. Or I can also say this is just 2 lots of x minus 3. This is just taking that immediate abbreviation shortcut. I have 1 and 2 lots of my x minus 3 length. I'm going to do that here. And to that, I'm going to add 2 lots of y minus 4 because I have 1 and 2 lots of y minus 4. So plus 2 lots of y minus 4. Now this looks a little bit scary because now we have these 2 expressions. So this looks a little bit intimidating, but if we just go through it slowly, you'll see that there's not too much of a difference in how we approach this stuff. So I have 2 expansions I have to do. I have here 2 lots of x minus 3, and on the right side I have 2 lots of y minus 4. So I can expand these by just multiplying the term outside the bracket by the ones inside the bracket. So I'm going to do these one by one, and then after that I'll try to clean it up. But right now this looks really messy, and you'll hopefully be able to see by the end of this video how algebra helps us clean this stuff up. So my first thing here, let's do these separately. So 2 outside of x minus 3, that is like saying 2x, because 2 times x gives me 2x. 2 lots of negative 3 gives me negative 6. And over here, I have 2 lots of y minus 4. And taking 2 times y gives me 2y. Taking 2 times negative 4 gives me negative 8. And what I want to do now is I want to just add this one and this one together. So let's shift these a little closer together. And I'm going to add them. I'm going to take this and I'm going to add it to this. So you can see hopefully that 2x and 2y, these are not like terms. So there's nothing I can really do with these two. I have to leave them as is. So here I just have 2x plus 2y. But I can do something with negative 6 and negative 8. Those two are just regular whole numbers. We can work with those. So I want to take minus 6 and subtract 8 from it. That gives me minus 14. And this thing here is my perimeter. So that is all I need to do. Now, what you saw was I just took each of these expressions and I expanded them one by one. Once I got to this line here, I had a pretty messy looking thing, which I've just rearranged into a nice expression when I compute my negative 6 and my negative 8 here. Now let's just find the area. We're not going to do anything too crazy with this, but how do we define the area? Well, we find areas by just taking one dimension, multiplying it by another one. If you need more background into this, I've made videos on this before, you can check those out. But I just want to multiply one by another. So all I'm going to do here is do my y minus 4 and times that by x minus 3. And that's all I'm really going to do for now. Anything after this goes past the scope of what we do this year in algebra. And I'm just going to write these in a simplified way by just putting them next to each other. So I have an expression for both my perimeter and my area. So what this allows us to do is we have a nice compact way of representing the information with these unknowns. So when we actually get values for these unknowns, let's call this part B, I can find different areas and perimeters. So if x equals 5 and y equals 7, what is the perimeter and the area? Cool. So what I'm going to do here is first, I want to find the perimeter. So I'm going to write that again. I'm going to write that expression I came up with. And that was 2x plus 2y minus 14. Minus 14. And all I'm going to do here, guys, is substitute my 5 into my x. And I'm substituting my 7 into my y. Sorry, that's meant to be 14. So let's write that in now. So I have 2 times 5 plus 2 times 7 minus 14. So 2 times 5 gives me 10 plus 14 minus 14. So these two here, 14 minus 14 gives me 0. So I have a perimeter of 10. Now I realize I didn't give you guys units here. So let's just say these are in centimeters. So I wind up with a perimeter of 10 centimeters here. And I can do the same for the area. Because my expression for the area was x minus 3, y minus 4. And I already have values that I've given you for x and y. So I'm once again in the same way that I did with my perimeter. All I need to do is substitute them into here. So in the place of x, I'm going to substitute 5. So I have 5 minus 3. In the place of y, I'm going to substitute 7. So I have 7 minus 4. And we can't forget there is a multiplication happening here. We are just, by putting these brackets next to each other, it's just a short and concise way in algebra to write a multiplication. So 5 minus 3 gives me 2. And 7 minus 4 gives me 3. These are just multiplying together. 2 times 3 gives me 6. But this is how we can apply algebra to solving problems, for example, in geometry or in measurement. We can go across disciplines in maths using algebra, and we can come up with these really nice condensed ways of representing a lot of different information. And we can get to these easy things by doing our techniques in algebra, by collecting like terms, by expanding, by maybe factorizing if we need to as well. But that is how we can apply it to some questions you may see in Year 8 algebra. Thank you so much for watching, guys. I'll see you in the next video.